Okay, so we have first of all it's an off ramp. So off ramp means it's a diverge section. Okay, so the last example which we did was for a merge section. This one is for a diverge section. The last one had 8 lanes. This one has 6 lanes. So this is quite different from the previous one. So it's a good thing that we are having a chance to do this. Okay, the free flow speed for the ramp and the freeway is given. Okay, so we don't have to find that out. Now we will move on to the calculation of flow rates. Now the flow rate for the ramp is given, the volume for the ramp is given, the volume for the uh, freeway is given, but that volume has the volume of the ramp as well. So first of all I will find out the volume of the freeway only. So the total is 4850, from which 800 is for the ramp. Okay, so the freeway volume is this much. Okay, secondly, I need the heavy vehicle adjustment factor for the ramp as well as for the freeway. Now both of them have 9% trucks and both of them have level terrain. Okay, so the factor will be same. So the equation for the factor is okay, now in this equation I have 9% truck, so PT is 9%. Okay, and ET for the level terrain, I have a table for that. This one. So for level terrain, ET is 2. Okay, how much is this? Yes, how much is the factor for heavy vehicles? Two minus one, yes. 2 minus 1. Sorry for that. This is 2 minus 1. Okay, so the factor is 0.92. Moving on, we will calculate the flow rate for the freeway and then for the ramp. Okay, so it will be volume of the freeway divided by peak hour factor. Okay, so the volume for the freeway was this much. Peak hour factor is given 0.93 and this one he calculated 0.92. Okay, so this will be for the freeway, and for the ramp it will be the volume of the ramp, and the rest of the things will remain the same. Okay, and for the ramp, okay, so the next thing we will do is find out the flow rate in the first 2 lanes. So I have a diverge section of ramp, so I'll be doing this. I need PFD factor. Okay. Okay, so I'll be using these tables. I have 6-lane freeway, so one of these equations. Which one will come from this table? Okay, uh, I have to look for the ramp before and the ramp after. Okay, is any data given for the ramp before and after? Yes, we have an upstream ramp, on ramp, half a mile, which has this much volume. Okay, so there's an upstream ramp which is half a mile far away from his this one, and it has a volume of this much. Okay, so let me go and check how to use this. So we have only upstream ramp and nothing downstream. So nothing downstream, upstream on ramp. Okay, so this one, this condition, and this condition we can use equation 5.35, equation 5.36, depending upon the length of the value of LEQ. Okay, now, and they are saying if this ratio is less than 0.2, we'll always use equation 5.35. Okay, so first of all, let us find out this ratio. This is flow rate for the upstream ramp, and this is the length to the upstream ramp. Okay, and the length is in feet. Okay, so I will convert it to feet. Now the volume is given for the ramp, upstream ramp, and the volume is 800. So first of all, I will convert it to flow rate. Let me just take a look. 900, sorry, 900. The factors are same because no change is given for it. So how much is this? So I'm calculating the flow rate and I'm converting the length into feet because the equation needs it in feet. Okay, and how much is this? Okay, so when we calculate the ratio, I need to calculate the ratio of flow upon length, right? Flow upon length. So flow is 1052 and the length is 2640. Okay, how much is this? Okay, so now you can see that it is more than 0.2, so I still have both options open for me. Okay, I can use 5.35 or 5.36, both options are open. Okay, so I need now LEQ. So upstream on ramp, this is LEQ, you already know VU. Okay, you already know the flow rate on the freeway and you know the flow rate on the okay, so we need flow rate for the freeway. Okay, what we calculated was without the ramp. Okay, so let me just okay, so what I did here was I subtracted and then I calculated. Okay, so we will add these together to get the full flow of the freeway. Okay, this is what we need here, the full flow. We need the full flow here because they are saying just in all lanes just upstream of the where is it, upstream of the diverge section, because we are doing diverge section here. Sorry for this mistake. So upstream of the diverge section. Okay, so that's what this will contain the ramp as well as uh, the freeway and the ramp both. So we need to add these two values. Okay, so how much is this? 4734 plus 9 935. How much is this? Okay, so we will use this here. Okay, so VU is 1052. Okay, so LEQ will be 1052.071 plus 0.5670 minus 0.0076 into the ramp, which is 935. Okay, how much is LEQ here? I'll just make a correction here. Okay, so my distance is 2640, remember, half a mile, 2640, and you found LEQ to be 8000 something. Okay, so LEQ is higher, D is lower. I will use equation 5.36. This is equation 5.36. Okay, so PFD will be 0.717 minus 0. Freeway, it was 5670. Okay, U upon L up, you already calculated it. This ratio you already calculated. It was 0.39. Okay, so I'll directly put the value here. So how much is this? Okay, so now I can calculate my first value for V12. Okay, V12 will be VR, which is 935. Okay, plus 5670 minus 935, 0.73. How much is this? Okay, 4391. Now I need to apply the checks. Okay, so the first check is the flow in the outer lane. I have only one outer lane, okay, so I don't need to do per lane every time here. So flow in the outer lane should be less than or equal to 2700. Okay, the total was 566 something, and you got in the first two lanes 4391. Okay, So if I do 5670 minus 4391, it is less than 2700. Okay, so the check satisfied. The first one satisfied. Second check is average flow in the outer lane, which is whatever value you have from here, should be less than or equal to 1.5 times the average flow in the other lanes. Okay, so the how much is this difference? How much is this? Okay, so the second check says that this 1279 should be less than or equal to 1.5 times 4391 per lane. Okay, so 4391 per lane. So how much is this 1.5 into blah blah? It will be more than I believe it will be more than 1279, right? Okay, if I do this one 4391 divided by 2, I will get 2000 something. Okay, into 1.5 times I will definitely get more than 1279. Okay, outer lane should be less than or equal to. Okay, so I am satisfying this check as well, so no problem here. Now we'll move on to the capacity checks. The flow rate on the ramp is 935. The free flow speed on the ramp is given as where is it, 35 miles per hour, and for the freeway it is 70 miles per hour. So 35 and 70. So if I come here, 35 is here, the flow should be less than 2000. My flow rate is 9000 something, 900 something. So I satisfy the first capacity check. Second capacity check, for free flow speed of 70, the flow rate per lane on the ramp should be less than 2400. Okay, now in the outer lane the flow rate is 1279. In the inner lane, how much is this? If you do this 4391 upon 2, it will be less than 2400, right? 4391 upon 2 will be something less than 2400. Okay, so this check is also satisfied. Then for a diverge section, the total V12 should be less than 4400 for a diverge section. Okay, this one should be less than 4400. My V12 is 4391. Okay, so this check is also satisfied. Okay, this check is also satisfied. So all checks are satisfied. Okay, the capacity check as well as the V12 check. If the capacity checks were not satisfied, I will put level of service F. If the last check for 4400 with V12 does not satisfy, I will put a comment, okay, that we can expect lower level of service actually, and I will continue. Okay, but in this case there is no comment required here. Okay, so now I will calculate the density for the diverge section. Okay, so this is the equation for the density. Okay, and LD was the length of the deceleration lane. Okay, which is given here. Length of the deceleration lane is 950 feet. Okay, so LD is 950. So density V12 was 4391. Okay, how much is this? Yes, how much the density? Okay, so according to this density, my level of service is D. Okay, this value between 28 and 35. Moving on, I can calculate the speed in the ramp area and the speed in the outer lane. Okay, so if I want speed in the ramp area, I need the value of ds. So ds equals 0.883 plus VR, which was 935, by 0.13013. Free flow speed of the ramp, which is 35, into adjustment factor. There's no condition given for adjustment factor, so I'll just simply keep it as it is. So how much is my ds here? Once I calculate the ds, I can calculate the speed in the ramp area, which is the free flow speed of the freeway, into, okay, so multiply by ds. Okay, so this will give you speed in the ramp area, the first two lanes in the ramp. How much is this? Okay, then speed in the outer lanes, I need to look at the outer lane volume. My outer lane volume was 1200 something. You gave it to me here, 1279. Okay, so it's more than 1000. I'll use the second equation for the outer lane. So speed in the outer lane equals 1.097 to 70 minus 0.0039 1279, the volume in the flow rate in the outer lane, minus 1000. Okay, how much is this? How come? 1.097 into 70. Okay, this will be how much? And then you are subtracting this value. Okay, so 75 point something. Okay, good enough. Ali, can you recheck if it is 75.07 or 0 or just 7? Or one of you can recheck if 07. Okay. So now we can calculate the overall speed of the freeway, okay, including both of the sections. Okay, so speed 75.7. Okay, moving on. So V12 is 4391, 4391 plus the outer lane, which is 1279 multiplied by number of lanes, which is 1. 1279 multiplied by 1. Okay, so it doesn't matter. Then v12 upon the speed of the ramp area, 4391 divided by 55.7 plus 1279 multiplied by 1. I'm just doing it so that you know that what I'm following. 75.7. Okay, so on the numerator you are adding the flow rates, and the denominator you are adding the ratio of the flow rate and the speed. So how much is the speed here? Yes, how much is this speed? Okay, so this is the overall speed of the freeway. Okay, 59.2 miles per hour. All the speed is in miles per hour. Okay, so this 75.7, 55 point something, these are all in miles per hour. Okay, so do you guys have any questions?